Yes po, ma'am.
Okay.
Let us put ourselves in the presence of the Lord, the name of the Father, and of the Son, and of the Holy Spirit. Amen. Heavenly Father, we come before you today with grateful hearts, thankful for the opportunity to gather, learn, and prepare for the calling you have placed in our lives. Bless each one of us here, Lord, as we strive to deepen our knowledge and sharpen our skills in environmental planning. Guide our minds and hearts to focus, understand, and absorb the lessons we need, not just for the exam, but for the greater purpose of serving our communities and stewarding your creation. Finally, Lord, remind us that our efforts are not ours alone, but for your greater glory. Stay with us throughout this journey and fill us with peace and confidence, knowing that you are always with us. All this we ask in Jesus' name, Amen. In the name of the Father, and of the Son, and of the Holy Spirit, Amen.
Thank you. So I'll not wait for the others. So let me proceed. Let me share. Uh, okay. I think we are here already. Mm. So I think you're able to see clearly, diba? So we're here on this slide. So let me define statistics. It's a set of scientific tools used to collect, organize, and interpret numeric and non-numeric data and to convert raw data into process information helpful to decision makers. So it indeed plays critical role in transforming raw data into meaningful information for decision making. So whether you're assessing population trends, evaluating project impacts, or profiling communities, you'll rely on statistical tools to make sense of the data you collect. So it also refers to scientific or to a set of scientific methods used to collect, organize, analyze, and interpret both numerics. I mentioned that already. And what's the purpose of converting raw figures into a form that's useful and understandable so that stakeholders would appreciate that and would and so that they will rely more on evidence to make policy or development decisions. So we have a core area here, as you see on the second bullet, that's descriptive statistics. So it consists of procedures used to present and summarize the information in a set of measurements to describe the characteristics of the whole set. So whether it's a sample or the population. Okay. So it's particularly useful when you want to capture central tendencies, meaning like the mean or median. Okay. And when you want to present frequency distributions also, and when you highlight patterns or trends through charts, tables, or graphs. So there are common tools in graphical descriptions or yeah, we have the bar charts, pie charts. We already have a wide options. So there are also many digital tools already available, especially after pandemic and even during the pandemic. And when we can also prepare tabular summaries when we do frequency tables, when we prepare that. Also, summary statistics like mean, median, range, standard deviation. So during our time and up to 2000, was it 19 or maybe prior, sobrang dami ng statistics questions. And so, hindi nawawala yung what's the meaning of mean, median, range, standard deviation as a terminology, and also meron computation. Okay? So for example, if you're analyzing population density across barangays, descriptive statistics will help you report the average when you identify outliers and show distribution patterns visually, so providing a strong foundation for more complex analysis. So, still on descriptive statistics, it's you can see categorical and continuous data. So, categorical data refers to non-numeric. That represents categories or classifications such as gender, barangay, or housing type. So the most common techniques used are frequency, okay, under categorical data. Means that it answers or yeah, it addresses how often, for example, a category appears. For example, how many households fall under each income bracket. And then we have the contingency table still under categorical data. This summarizes the relationship between two categorical variables, such as education level and employment type. So this is often presented in cross tabulations. Continuous data, on the other hand, they're numeric, while categorical data is non-numeric. Okay, so uh, continuous data are numeric and measured on an interval or ratio scale. These include population size, land area, rainfall, and income. So descriptive statistics or yeah, for continuous data are classified under 3 dimensions. So we tackle location first. These are measures of central tendency. Central tendency because it comprises mean, meaning you're solving average. And there are many ways to do that. Arithmetic, geometric, and harmonic method. Then median is the middle value. Okay, middle value in an ordered set. Please remember those. Although we took them as early as during our high school, diba? Sa high school days. So we've been computing ano yung median, so the middle value in an ordered set, and the mode, the most frequently occurring value. And these indicators help identify the center or typical value in dataset. So there are all measures of central tendency. Dispersion. These are measures of variability. Okay, yung kanina, central tendency, now measures of variability. Range because it measures difference between the highest and lowest values. While standard deviation is the average distance of values from the mean. Okay? Then coefficient of variation, this is the standard deviation relative to the mean. And then percentiles are the values below which a given percentage of observations fall. This tell us how spread how spread out or clustered the data is. Then shape, okay, it includes skewness, meaning the asymmetry of values. and also kurtosis, thickness, and then uh, variance moments and other specialized metrics like semivariance. These are useful in understanding the pattern of distribution of values, whether the data is symmetrical or skewed to one side or has outliers. So they're all used to analyze, for example, in the context of our field, environmental planning, it's used to analyze community profiles if we are also evaluating program results, and prepare technical reports. So, okay. Inferential statistics and hypothesis testing. After describing data through descriptive statistics, the next step in many research efforts, especially those intended to inform policy or evaluate interventions, is inferential statistics. And this allows us to make generalization about a population based on a sample or assess the significance of observed patterns and test assumptions using data. So first we have inference. This refers to drawing conclusions about a population based on sample data. Um, confidence intervals estimate the range within which a population parameter lies, okay, with a certain level of certainty. Then Bayesian inference, it uses prior knowledge to update the probability of a hypothesis being true. Then significance testing there helps determine whether observed results are due to chance. Okay, and then meta-analysis combines findings from multiple studies to improve reliability. So in planning, these are applied when evaluating program outcomes or population behavior using limited samples. Then design of experiment, this involves structuring the study in a way that minimizes bias and maximizes the clarity of results. Controlled experiments allow for the highest control over variables. Natural experiments and observational studies are more common in planning practice due to real-world constraints. And then replication and blocking help ensure consistency and reduce the impact of variability. So in our field, this might relate to evaluating the impact of, for example, in my upcoming webinar or online event, so that it might relate to evaluating the impact of a new waste management strategy or technology by comparing pilot and non-pilot areas. Okay, for example, in that particular, in those case studies on waste management, we can evaluate or we can compare uh, the new waste management strategy or technology in a city context or city level or a lower class of municipality. Okay, so sample size determination, this ensures that the sample use is statistically sufficient to detect effects or represent the population. Concepts like statistics or statistical power, effect size, and standard error guide how large a sample needs to be. Then range, standard deviation, and coefficient of variation measure spread, while percentile ranks can guide cutoffs in policy targeting. This is particularly relevant in surveys or household level studies where sampling must reflect demographic diversity. Um, General estimation, so we're now in the fourth area. These are methods for estimating population parameters based on sample statistics. Techniques like Bayesian estimation, maximum likelihood, methods of moments are used in more technical statistical modeling. These approaches are foundational in predictive modeling, risk analysis, or advanced policy simulations. Then specific tests are these are used to formally test hypotheses about relationships between variables. So it's no longer new to you about z-test, t-tests, so and chi-square test. They're commonly used for comparing means or proportions. Then the Mann-Whitney U uh, and Wilcoxon sign rank tests are non-parametric alternatives when assumptions like normality are not met. So in planning, these tests help validate assumptions such as whether land value differs significantly across zoning types or if access to water services varies by income group. Okay. So this entail a step-by-step flow of how statistics is applied in research, from formulating the research question to testing hypotheses and drawing conclusions. Um, and you can see the structured diagram there that it shows relationships between descriptive and inferential statistics and the tools used um, in each aspect of statistics. When we define the research and formulate hypothesis, let me just check. Okay. The process begins with defining a research problem, okay, and identifying what you want to investigate. This could be a question like, okay, does proximity to public transport influence household income? So that one of the research problem that I can think of. Then once the question is clear, you gather data through surveys, observation, or secondary sources. So this data becomes the foundation for analysis. Then descriptive statistics, sorry, summarize your data set to make it easier to understand through percentiles, quartiles, median. So they all help describe position with the data set. Then you need to measure central tendency. I mentioned earlier, they include mean, median, mode, and then the measures of dispersion describe spread, such as variance, standard deviation, and coefficient of variation. These tools are especially useful in presenting socioeconomic profiles or baseline studies. So, isn't it in the CLUP, before we go to the different volumes, we prepare a socioeconomic physical profile, the formerly known as the SEP, SEPP. Then now it's called ecological profile. So first things first, before you can do that effectively, I mean the CLUP process, and you need to make great efforts on preparing the ecological profile. So, about inferential statistics, this allow you to make generalizations from your sample to a broader population. It includes confidential Okay, confidential or confidence intervals. Confidence intervals. So this is quite topsy-turvy. So I'll proceed with confidence intervals. They estimate the range within which a true population parameter is likely to fall. Then hypothesis testing, okay, you can see the arrow down there, that it checks if your assumptions like difference in means or relationships between variables are statistically valid. So it checks if your assumptions are statistically valid. If testing one sample, you may use you can see there one sample, then no question mark done. You may use a t-test, okay? A t-test to compare a sample mean to a known value. Then chi-square, okay, x-square or the chi-square test to evaluate variances or distributions. If comparing two samples, you use a t-test for comparing means. So if data is continuous, use a chi-square test if dealing with categorical variables. As if I'm teaching a master's degree, ano, kapag ganito, no? Parang ako yung statistics teacher nyo. But I just need to review nga, no? So we need to do it one by one again. So I understand when you did your master's, and I am hoping you really did, na meron kayong mga ganito. I'm not sure if you had thesis. May thesis ba kayo? I can. Segfir, sa PCU, si Mark, did you have thesis?
Non-thesis po yun, ma'am.
Pero nag-ano kayo, ano na yun? Compre?
Opo, ma'am.
Ah,
Meron ding parang research pero hindi talaga. Compre lang yung sa ano.
ah, ah. Hindi kayo nag-project ng CLUP, ganon? Na gumawa ng isang CLUP? Walang ganon?
Wala, parang yung sa mga transport plan, mga ganun lang.
Um,
Iba-iba, depende sa teacher, ma'am.
did you do a transport plan? So in your
Ah,
case,
mga part lang yun.
hindi siya buong plan.
Mm-mm.
I see. Hmm. So, okay. It's okay. Measures of association. Okay, one, two, three. Nandito na tayo sa measures of association. These are used to examine relationships between variables. Okay? Correlation measures how two continuous variables move together. For categorical variables, tools like phi coefficient, okay, or Kramer's V are used to measure strength of association. Ang daming terminologies dito eh. And then, of course, my favorite talaga is regression kasi may simple, meron ano. So I remember when I was still young at my 20s yet or 30s, when I was teaching statistics talaga sa graduate school, no? So favorite ko yung multiple regression. So I hope all of you understand what's regression when you want to understand or predict the influence of one or more independent variables on a dependent variable. Then regression analysis is used. I will repeat that. When you want to understand or predict the influence of one or more independent variables on a dependent variable, regression analysis is used. So it's widely applied in planning, whether to estimate land values, when you forecast population or evaluate policy impacts, and you really cannot get rid of regression analysis. So, okay. Um, we are 'di ba, I mentioned about central tendency or the middle region when you are, okay, they're used to identify the middle or typical value in a data set. These are some of the most fundamental and frequently used tools in descriptive analysis, especially when analyzing household income, um, land values also, age distribution, or any other planning related data. So, so again, ilang beses ka nang binanggit, there are three main measures, mean, median, mode. Okay? So I remember when, when I was uh doing review classes face to face, and I normally come up with like 50 to 100 questions, on just mean, median, mode, hanggang sa magsasawa ka, and then kahit nakapikit ka na, you do understand what's the role, or what's mean, median, and mode, parang ganun. So mean is an arithmetic average. It's the sum of all observed values divided by the number of observations. 'Di ba? You remember? So x bar equals summation of x over n. So it's sensitive to extreme values, or outliers, which can pull the mean upward or downward. So in planning, it's commonly used for calculating average household size, average travel time, or average income. So how about mode? The mode is the most frequently occurring value in a dataset. So ano yung pinakamarami, right? So it's simple. So it's useful for identifying the most common categories, such as the most frequently reported income bracket or most common land use type. So unlike the mean and median, a data set may have one mode, which we call unimodal, and then two modes, bimodal, or more, multimodal. So that's about mode. So median naman is the middle value in an ordered set. So if the number of observations is odd, it's the middle item. Automatic yun. So even if you don't calculate. And if even naman, it's the average of the two middle items. Okay? So, i-ano mo yan. So, yung dalawang nasa gitna, take the average of two middle items. So, it's less affected by outliers, making it a better measure of central tendency when data is skewed. The median is frequently used in planning to represent typical income or property values where there are large gaps or extremes. Now, the perfectly asymmetrical graph there, you can see, shows mean, median, mode, and this is common in theoretical models. So the skewed distribution shows the three measures diverging. In a right skewed distribution, common in income data, the mode is lowest, followed by the median with the mean highest. Okay. So, what's the practical application for planners and why do we need this? You use mean when the data is symmetrical and free of outliers. You use median when you need to reduce the effect of extreme values, and you use mode for categorical data or to identify the most common category. So we need really this tool. Okay. Now, for the measures of, just a moment. Hang on. I'll just drink. So we have range. The range is the simple or the simplest measures of description or dispersion, sorry. And it's calculated as the difference between the highest and lowest values in your data set. Example, if the smallest household size is 2 and the largest is 10, the range is 8. If it gives a quick sense of variability, but it's very sensitive to outliers. So, okay. Variance, on the other hand, tells us, okay, how much the data points deviate from the mean on average. So, we can see the formula there, okay. S square is equal to summation of yi minus y bar square all over n minus 1. So, it's a sample. Pag ano naman, pag population, meaning the whole, okay, data. So, rho ba yun? Ano na yung symbol na to? I forgot. Is it rho square? Equals summation of yi minus mu. Is it mu? Then square divided by n. So, the first, of course, we subtract the mean from each value and square each result, right? Take the average of the square differences, and then a higher variance means more spread, while a lower variance indicates consistency. For standard deviation is the square root of the variance, all right? Unlike variance, standard deviation is expressed in the same units as the original data, making it more intuitive. It's also widely used in planning reports to describe variability in income, land prices, or travel time. When you obtain a smaller standard deviation, it indicates that most values are close to the mean, while a large one suggests wider variation. So why this matters in planning? And we need to, it's important to know the average access to water or income level, but we also need to understand inequality, the gaps, anomalies, etc. And variance and standard deviation help in targeting interventions more precisely and explaining data reliability in reports, assessments, and projections. So we have descriptive statistics here. Okay. And there are, okay, that's just to show the types of data displays, for, of course, the bar charts, the line graphs, and run means trend charts, because trend shows changes over time. For the bar chart, we use this to compare quantities across categories. For example, when we compare population by barangay or revenues by LGUs, we use the bar chart. It can be simple, it can be grouped, or it can be stacked. Pie charts also. So, by the way, for the line graph and trend charts, it's useful in tracking variables such as land conversion, household growth, or annual disaster frequency. So pie charts also shows parts of a whole, especially when we do yung mga major industries like primary, secondary, tertiary, and then we have ano to, the other types of industries. So we do pie charts. So it's also best for illustrating proportions such as percentage of land use types or budget allocations. Now we don't need to do that through Excel, or I do that now in Canva. There are some apps there on the left side of that. I'm not sure if some of you here are using Canva. It could be, very creative to um, leverage on the Canva tools. Kasi ito, hindi na siya ginagawa elsewhere. But, it's the most convenient is baka may mas mataas pa sa Canva, no? But if you want to do some creative reports, then you can try using that. So histograms also, we show distribution of continuous data, group into ranges or intervals, and it's useful for visualizing frequency distributions such as income brackets or age groups. Venn diagrams also, it's one of my favorites. Kahit hindi kailangan ma-Venn diagram, Venn diagram ko, because nakakatuwa lang talaga yung tool, that it illustrates overlap or shared characteristics among sets. It's also helpful in conceptual analysis or when comparing policy domains or stakeholder roles. So even during the time that I was preparing, I remember, just to share, I was preparing the strategic planning because PIEP then had, factions. And so I do Venn diagrams for all the things that naiisip ko, just to make some illustrations on bakit nagkaroon ng faction, and how elections are being done, how all this but parang it seems na parang other people would appreciate, pero konti lang. And most people, siguro, because nakakatamad maging perfectionist minsan, but for purposes of clarity, you can leverage this one. Okay, for example, dapat 10 pages yung report mo, and then you can only do one to two pages when you have frameworks, when you have this type of presentation. It would be good for planners. Okay. So, kaya nga, even when I was doing law, I illustrate everything, like even recommendations in policies, mga ganun na ang araw, ay wala pang apps noon, but I make use of a one pager review material, to just to illustrate, conceptualize. So, ano yung mga because nakakalito yung yung one law to the other, and there's the special law, and then there's the for example, the the revised penal code, and then nag-criss-cross lahat yung mga policies. So, even lalo na for if you are a planner and you cannot capture everything in a one page. So if you can practice that, especially for those of you here who are specializing in GIS, it should be the most organized, the most evidence-based report if you illustrate your work together, and you always provide maps for all the things that you want to say, and for all the strategies that you want to say, and then or to express in that report, to make it more credible, and integrity is preserved when you have all those things. Okay, so but then why is not there? Okay. Inferential statistics. So what's inferential statistics? So it involves, sabi niya dito, draw conclusions, make predictions, test hypothesis, estimate unknown values, and make informed decisions about populations based on that data gathered from samples. For example, in planning, we rarely survey an entire city, so cannot really do that. Pero pwede na siguro because we already have GIS, and you can drone everything that we want. And so instead, yeah, during our time, we cannot do that. Yung we use acetates for analysis, mga maps. So like overlay yung mga acetate. Now you can do that through GIS. So meaning, yeah, just for purposes of understanding inferential tools. So it helps us estimate or assess conditions across the entire city or the population or the sample, if we leverage on this inferential statistics tools. So ano pa? Yeah, what are the key uses in planning research? So we estimate parameters. Okay, we estimate parameters such as average household income or satisfaction level using confidence intervals. Then when we test hypothesis, it means that we assess whether observed differences between halimbawa through two resettlement sites, uh, do we assess whether observed differences are statistically significant or likely due to chance only. Then, when we generalize findings such as using a mobility survey from 300 respondents, for example, to infer behavior patterns of a larger urban population. So we are trying to generalize our findings. When we compare groups, whether two communities differ in terms of flood risk, awareness, or access to services. So this is how the role of planning research. Then, of course, discrete nakalagay dito. Okay. Inferential statistics help in making judgment of and observe the difference between groups is a dependable one or that might have happened by chance in a study, discrete random variable. Meaning, yeah, these are countable outcomes like number of vehicles. Then continuous means there are measurable outcomes. Okay, like household income. Countable, measurable, so they belong to random variables. So normal distribution means that that's a bell-shaped curve that many variables follow, like test scores or height. Z-table used to calculate probabilities and confidence levels in normally distributed data. Then confidence intervals are they estimate the range where a population parameter like the mean likely falls based on your sample. Hypothesis testing is a framework for assessing whether the distances or the differences you observe are statistically valid. So, okay. So you can see sample, then population, the diagram. Yeah. So the goal of inferential statistics is to make statements about the whole population using only the data from the sample, and so population is the whole thing. Inferential statistics, again, inferential statistics, I can see there. Okay. So you know already, okay, I don't need to keep saying that the population is the full set of units we are interested in studying. So it could be all households in a city, all barangays in a province, or all LGUs in a region. So, okay. So inference now, okay, inference. is the process of using a sample statistics or sample statistic to make an estimate of or judgment about a population parameter. So, for example, if we survey 300 households and find the average monthly water bill, yeah, for example, 500 pesos. So we use inferential statistics to estimate the average bill for all households in the city. I still okay. So what's that sample frame? It's the complete is the okay, it's a list of all the individuals units in the population from which the sample is taken or drawn. What are these examples? You can see, for example, yeah, directory of households, a list of the registered voters, registry of schools, roster of barangays. So your sampling frame should closely match the population you want to study to avoid bias. Now there are some this is just a review, okay? You already know this, but just for memory recall, kaya review, no? So simple random sampling, yeah, every unit in the sampling frame has an equal chance of being selected. Like probably the exam questions, right? So every question, even if it's already an outdated, as long as they have not been taken out of the database, so it will still be selected as yeah, you have to recall the simple random sampling. Every question, for example, in the sampling frame or in that particular example, all questions in the database shall have equal chance of being selected. So, multi-stage sampling. Sampling is done in multi-stage. Okay, so hindi niyo siguro makakalimutan ito because it's done in stages. Parang keyword lang ba? So first, selecting larger units like barangays, then sampling individuals within them. Useful for large geographically spread out populations. Then stratified random sampling is when so hindi nyo rin ito makakalimutan because by the word stratified, meaning you divide it into strata. For example, income levels, barangay size, and random samples are taken from each stratum. It ensures representation across important subgroups. Then systematic random sampling are you list all units, assign numbers, and select every nth unit, like every fifth household, ganun. And quicker than simple random sampling, but requires careful ordering. So that's systematic, okay? Cluster sampling, instead of individuals, groups or clusters like entire puroks, mayroon ba tayong entire barangays, they are randomly selected. It's cost-effective for field work covering large areas. Convenience sampling, it's you select units that are easiest to reach or available. Kaya nga convenience, di ba? So, hindi nyo ito makakalimutan. Or you can immediately, you know, ano to, you can eliminate, di ba? Na, okay, convenience because they're easiest to reach. While purposive sampling, you select individuals who are specifically knowledgeable or relevant to the topic. So they're common in key informant interviews or stakeholder analysis. So purposive, like siguro yung, so which examples you can do here, like, yeah, probably focus group discussions, right? Or it's if we're just talking to farmers, ganun. So they're the ones directly affected by a new or what's this? They have been if a policy was changed or they have been repealed, mga ganun, ano? So you call people who are directly affected. So but that's purposive sampling. So quota sampling, you select respondents based on pre-specified categories because quota, so ensuring certain percentages from age groups or income brackets, and it's similar to stratified sampling but less strictly random. Okay, so mas pan yung yung ano stratified. It's more strict, okay? Um, Importance, so what's okay, you can already. So, kapag ka mapapa-exam ako ng 1, 2, 3, 4, 5, 6, 7, 8, siguro mapa-perfect yun na, no? Itong types of sampling methods. So selecting the right sampling method affects the accuracy of your findings, the credibility of your reports, the applicability of your recommendations. For example, a poorly drawn sample might mislead an LGU into misallocating resources or incorrectly prioritizing results or prioritizing projects. So all those when, especially when we're needing specific stakeholders. So like 4Ps, mga ganun. Okay. So I can go there. Something techniques. It's the process actually of selecting a subset of individuals. Okay. Or units from a larger population to make inferences about the population. The technique you use affects the validity and reliability for studies. So, yan, are already, but I remember itong ano na to, itong snowball na to. It was given a number of times. Ano yung snowball na yan, di ba? So, I did not talk about snowball, but yeah, snowball means even in AICP, yung American Institute of Certified Planners, mga exams they give snowball. So I remember this one teaching and clarifying this one that current participants, for example, recruit future participants, so useful in hard to reach populations like informal settlers or special interest groups. Yun pala yung ibig kong sabihin kanina, lalo na focus group discussions. So you need people special interest groups. So, coefficient of variation CV is defined as the average percent estimating error when predicting subsequent observations within the representative population. It's the ratio of the standard deviation to the mean. The standard error of the mean depends on the standard deviation of the population, the size of the sample, meaning the smaller the standard deviation of the population, the smaller the error. The larger the sample size, the smaller the error. So, yeah. Ibig sabihin, the CV helps us do this in a, in a standardized way, okay? That, for example, it tells us how much variability exists relative to the average value. It's especially useful when comparing the spread of two or more data sets or data sets measured in different units or with different magnitudes. So you can see the formula there. CV is equal to SY divided by Y bar or rho over mu. Oh, Y or mu is the mean and the SY or rho is equal to standard deviation. So please correct me when I'm wrong. Dun sa pagkuhan ko, I forgot already the symbol. So, a higher CV means greater relative variability, meaning more inconsistency compared to the average. And a lower CV means the data points are more consistently closer to the mean. For example, if two communities have similar average household incomes, but one has the higher CV, that community shows greater income inequality. Okay? Because I mentioned kanina that a higher CV means greater relative variability. So more inconsistency compared to the average. So the standard error of the mean describes how accurately a sample mean estimates the population mean. It depends on the standard deviation. The smaller SD leads to, mentioned earlier, leads to smaller error. And in the sample size larger, sample sizes reduce error. I'm not sure if you're getting it at this time. It's almost 11, right? So does both CV and standard error of the mean, SEM, okay, SEM, relate to data reliability and how much confidence we can have in our statistical inferences. So when analyzing, for example, indicators such as household income, building densities, or utility consumption across districts, use the CV to identify areas with high internal variability and use it to compare consistency across projects, programs, and communities. So if you're reviewing, for example, two urban redevelopment sites and one has a CV of 12% for household size and the other 35%, for example, as CV. The second site shows how much more variability and may require a different planning approach. So, what's a covariance? It says a measure of how two variables both vary relative to one another. So variance shared by two variables. Covariance reflects the direction of the relationship. Okay. So it reflects whether increases or decreases in one variable are associated with increases or decreases in another. So there's a formula there. Okay, of the covariance. So X and Y are the two variables. And X bar and Y bar are their respective means. Para lang alam natin ano yung nasa loob ng formula. And N is the number of paired observations. And so they're computed by multiplying the deviations there of each observation from the respective means. That when you say positive covariance, yun sa baba, okay? Positive covariance means that when X increases, Y tends to increase. When X decreases, Y tends to decrease. So for example, so what do we mean by that? Why this formula are up there? Because, for example, we can use that, for example, a household income increases, as a household income increases, average floor area of housing may also increase. So negative covariance there, when X increases, Y tends to decrease, parang opposite, okay? When X decreases, Y tends to increase. So I'm just thinking of an example like, as distance from the city center increases, land value typically decreases. Like I remember, sino na yung may theory nito? Yung sa agricultural, yeah, I forgot. Sino na yung who can remember that? Unmute. That theory, um, that's why it's concentric. And so because those in the nearest to the center are those perishables that when you translate it into into transportation, and so the greater the distance, as distance from the center increases, the land value typically decreases, and so it's cheaper there at the outer concentric circle. Sa dalawa yung pwede kong ano doon is maalala. Dalawa yung theory. But anyway, at this time talaga, pag 11, mahirap nang makapag-isip, but I know na, na you can recall that if you want. Ang dami, actually 3, 4. Madami. So, anyway, I'm just trying to relate our definitions here with theory that we did last time. So, pero kung kaya na niyang mag-unmute, sige, okay lang sa akin. So, let me just finish few slides. So, coefficient of determination, it's measuring how well one variable predicts another. Okay. So when conducting research or analyzing planning data, it's not enough to know that two variables are related. So, and we also want to know how much of the variation in one variable can be explained by the variation in another. So, di ba yung kanina, we were talking about, if this increases, it also increases. And if this decreases, it also decreases. Mga ganun na, x, blah, blah, blah. And then, another one is that if it's negative, if one increases, then it decreases. And if it decreases, it increases. Parang ganun. So, here, it's concerned about the, yeah, how variation also, variation in one can be explained by the variation in another. I'm not sure when you were in college or when you were in high school or maybe here in your master's or PhD, if you came to a point that you really appreciate the definition of terms, and if you can relate that in the field that you want to pursue when you were younger, kasi kapag mas maiintindihan mo ito when you become older, when when you have defined already where you are right now. For example, some of you here are real estate practitioners, and you know already who you are in terms of the career that you have pursued or you want to pursue, or how you wish to diversify further. And so, mag-i-increase din yung appreciation mo sa mga ganito. Noon, you just have to memorize it. But when you're taking another board exam, and it's something like a higher level of, board exam. So, we understand that in a way that you're not just memorizing. And so that's actually my goal as a mentor, that not for you to memorize everything, but to understand more than you have understood before when you were younger. Kasi for sure yung mga ganito hindi niyo na ito inaalam at this time, unless you're a professor, di ba? Na nagti-teach kayo lagi consistently on statistics, and pero ito we just need to understand, not really memorize, because that's why I always, even for a very simple concept, I try my best to put out an example in and contextualize it, because that's the only way I can make you appreciate. Otherwise, puro memory work, and it will really magpo-produce yan, mababurn out kayo. Because memory work is not really, simply I don't advise. Even for lows, ganon, you just need to correlate it or relate it to something funny or very serious or weird or something. Parang ganon, no? And so, yeah, now we're in coefficient of determination, R square. So, we need why it's important. Ano ba yan, di ba? So, R square measures the proportion of total variation in the dependent variable y. Okay? Dependent variable y. That can be explained by the independent variable x. So, if you have that, x and y axis, so the y is the dependent variable and the independent variables, the x-axis. So, this variation ranges from 0 to 1. R square is equal to 0 means none of the variation is explained by the model. And R square 2 equals 1, sorry, means that the model explains all of the variation. Can you see that? Can you appreciate now? So, R square, okay, is explained variation versus total variation. So, you expand that by summation, blah, 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 okay? And where yi is the actual values, y bar means the mean of actual values, and y, ano na yung ganun, hat, ano yung may parang hat, di ba? So, these are the predicted values. So, a higher R square, sorry, value indicates that a larger proportion of the variability in the dependent variables is accounted for by the independent variable. And if, for example, if we have obtained R square equals 0.8, for example, then 80%, it means 80% of the variation in land value, say, is explained by distance to the city center. So, and 20% remains unexplained by the model. Kasi 0.8 lang yung nakuha mo. So, nakita mo na yung coefficient of determination R square. It will provide you an overview of the dependency or the account when you are trying to yung attribution ba, you attribute this and this because of the model. Okay, so in planning, the coefficient of determination is crucial or is important for evaluating predictive models, like when you try to forecast housing demand based on population growth. And for example, another one is when you assess the strength of relationships. So ano yung example ko doon, like urban sprawl and traffic congestion. Then, when you, then ano pa yung coefficient of determination, I can also give like, it also supports evidence-based decisions kasi, di ba, it's my advocacy as to incorporate evaluation into planning studies, that we make sure we are able to measure everything here, measure how the intervention are addressing really the root causes, or when you do root cause analysis, problem tree, etc. Ang dami-daming tools. And these evidence-based decisions, for example, when you select intervention areas based on predictors or vulnerability. So we would want to get to or to obtain coefficient of determination of higher value so that it can explain everything, the how yeah it's likely to um it affects or it's likely to account, okay, by the independent variable to the dependent variable. So normal distribution, few slides. Mm, In the field of research and planning, many natural and social phenomena, such as income levels, household sizes, or even traffic volumes, tend to follow normal distribution. So, understanding this concept is fundamental when interpreting data, applying statistical tests, or making projections. So, what we are now talking about normal distribution. Let me see. Okay. That it is okay. Can you see those bell shape there? So the normal distribution should be is continuous and bell shaped. So that's the one key feature. It is also symmetrical or but it is symmetrical around the mean. The left and right sides of it, meaning the left and right sides of the curve are mirror images, same, okay, because it's symmetrical. It describes many real world variables in nature, industry, research. So because of its importance, it's often called as the Gaussian distribution after Carl Friedrich Gauss, who studied it extensively. Ano kaya biglang ibigay yan, ano? So, I would like to see the day na ako naman yung magpapa-exam siguro, no? And then I'll give those unexpected questions. Siguro, konti lang makapasa, no? But anyway, it's good I'm not the one. I'm not the examiners. Otherwise, 1% lang siguro makapasa, no? I'm just joking. Okay, at this time, I just want to put a little smile or sarcasm in your face. Anyway, mathematical expression, naku, ang dami, no? The normal curve is defined by the formula. Yan, ang dami. N. N equals expressed in x rho, so equals to 1 over square root of 2 pi rho squared e raised to the negative or to minus 1/2 x minus nu over rho square. Okay. So, ano mga yan, di ba? Parang, grabe naman, ano? Grabe. And we can already, we don't do that anymore. I mean, everything is done by statistical tools na they are pwedeng sa computer na lang, we don't know. But, all these equations explains something significant. They're not there because they're not needed. They're there because it's needed. Parang ganun, ano? So, equations make up our world. So, that, alam nyo ba yung values pa yan, no? Nakikita nyo, yung pi, 3.149. So, even in your app, try to search for an app pi, okay? Pi. So just imagine nasa app na lang siya ngayon and you mine that, 'di ba? Magma-mining ka every day so to increase your sa mga ganun. Ginagawa ko din 'yun like a game. So, 'yun 3.1459. Baka kasi tanungin din yan sa board eh. So what's the value of pi? 3.1459. Kayo ba you remember? So madali lang eh, 3 tapos 14, increase mo ng isa, naging 15, and then 9, di ba? And yung exponent mo, Can you remember? 2.77, 18, 28. Madali lang din, di ba? 2.71 yun lang yung kailangan, 2.7, yun lang yung kailangan mong matandaan. And then 18 increased by 10. Ngayon, while you are seated, try to 3.1459. And then exponent 2.7, 18, 28. It's weird, but it might be asked. Okay? What are the values of exponent and pi? So, okay. When you, okay, the spread, ano pa yung nakalagay dyan? Okay. The spread or width, okay, of the curve depends on the standard deviation. So larger standard deviation is wider, it's flatter curve, di ba? Kapag iwa-widen mo yung curve na yan, siyempre, it becomes flatter, di ba? So, madali bang ano yan? Imagine, and the smaller standard deviation is narrower and steeper curve. So, ano ba yung relevance niyan when we contextualize and we transfer this one statistical concept to make it to be in planning. So, when estimating needs, di ba, sa CLUP, we compute housing demand, water supply, we determine how water supply and health services existing or current versus demand. Halimbawa, when you project 5 years, for example, or 10 years. So, when estimating this, assuming normality allows planners to apply statistical models. So, yun yung mga relevance niya. And then, meron tayong mga inferential statistics like t-test, confidence intervals, ANOVA. They assume this one assume that the underlying data is approximately normally distributed. Okay, just remember all those. And then, recognizing, halimbawa, kapag it's no longer normal, parang ganon, and you are departing from normality, meaning, highly skewed income and income distribution. So, it helps in selecting the correct analytical methods. So, ibig sabihin, it's not the tool that you are selecting if it departs from normality. So, ano pa? So, normal distributions, empirical, grabe naman yan, ano? So, okay, chi-square. Okay, so dito na lang, dalawa na lang. Please be patient. So, T-distribution is completely characterized by only one parameter, the degrees of freedom. So the degrees of freedom is equal to n, the sample size minus 1. Okay? The T-distribution looks like a standard normal, but has heavier tails. Okay? As n increases, the T-distribution begins to converge to a standard normal. You can explore the T-distribution on the sample Excel worksheet. Okay. Okay. So the T-distribution is one of the most important probability distributions when working with small samples. So it's more appropriate for small samples, and it allows us to estimate population parameters even when the sample size is limited and the population standard deviation is unknown. And so the T-distribution is characterized by a single parameter, the degrees of freedom, DF, okay, DF. And they are simply the sample size minus 1. So DF equals n minus 1. Okay, so it looks similar to the standard normal distribution because of the bell curve that I've been earlier, bell curve, okay? So, but it has heavier tails. Bakit? Di ba yung bell curve is ganyan lang siya? Pero tingnan niyo yung sa T-distribution, mas extended siya. And so this Ano yung meaning yon? Bakit ganun? And this reflects more uncertainty, okay, when working with small samples. As the sample size increases, okay, the t-distribution gradually approaches the normal distribution. So yung tail niya lumiliit, okay? So, and in large samples, for example, typically n is greater than 30, the differences become negligible. Anyway, we're not taking the statistics exam anyway, planning exam ito. So, just to familiar, kasi sayang pa baka we skip everything pala and then biglang, ano no, biglang si computer ay, yan yung lahat pinull out niya, di ba? Sa computer. So, now, the blue curve there represents the t-distribution. Okay, the t-distribution. And so the dashed curve is represents the standard normal distribution. So you notice how the t-distribution is wider and flatter with more probability in the tail. So this accounts for greater variability in smaller samples. So why are we doing this? I mean, sobrang namang ano no? Sobrang weird. So when making estimates like confidence intervals or conducting hypothesis tests based on small samples, we rely on t-distribution. For example, I translate that to a sample, an example, illustrative example. For example, if you're trying to estimate the average daily water consumption of households in a newly developed subdivision with only 20 samples, then you would use the t-distribution, not the normal distribution. So, last one, chi-square. Okay, bukas na yan. So, Sunday pala tomorrow, Monday na lang, okay? Chi-square kasi mamaya lalong kokonti tayo pag magsisipag pa ako ng Sunday. But anyway, I'm just concerned about you can read and kasi medyo mahaba pa to. The chi-square, ano naman yan, di ba? X square. So distribute is a critical tool when we are working with categorical variables and want to assess how observed results differ from expected outcomes. So the chi-square distribution is always skewed to the right. I mean, skewed to the right naman. Parang left naman yan. um, especially for small degrees of freedom. So to the right talaga yung skewed niya na. As the degrees of freedom increase, the distribution becomes more symmetrical, approaching a normal curve. It's used primarily to test or for tests of independence, the goodness of fit, and homogeneity. Degrees of freedom in a chi-square test are typically based on the number of categories or classifications minus some adjustment. For example, in a simple goodness of fit test, degrees of freedom are, okay, DF equals number of categories. Do you remember the N minus 1? Okay, so the more degrees of freedom, the closer the chi-square curve approaches a normal distribution. And so, how to read the table there? So, kahit sa libro kasi ito galing yung itong how to read when you read the table there, bakit may ganyan. 3.841. I remember during our time, the next mga 5, yung dire-diretso hanggang 20, siguro 2018 or 17. Madaming table. Okay, madaming table. So one problem would normally consist 1 to 2 pages, pero isa lang yung ina-answer mo doon, right? So parang super, ang hirap mag-refer from one page to another. Parang ganun. So in the example there, degrees of freedom R equals, dali. R equals, sorry, 2. And then at 0.05, 0.05, significance level. It's 0.05. But, ano to? Phi alpha or no, kalimutan ko na to. Ano yan? It's 0.05. So the critical value is 3.84. Ito siya. So, anyway. Basta, it's trying to point to 3.8841. Because, yung, asan, hindi ko nakikita yung 0.95. Anyway, later, later na lang. Because I cannot really see it. Ano tong example niya dito? So, basta, the table shows critical values of chi-square for different degrees of freedom that at different significance levels, commonly 0.05 or 0.01. So this means that if you compute x squared, statistic exceeds 3.84 or 8.841, you reject the null hypothesis at the 5% level of significance. So the shaded area, go back to the graph, represents the rejection region. Okay, the shaded area, the one that has been para nag-graph siya, diagonal. And then if the calculated x square value falls in this region, there's enough evidence to conclude that the observed and expected values differ significantly. So, chi-square, in planning, tests if land use distributions differ between two barangays, or when you examine whether the preference for a mode of transportation, like when you interview, for example, I prefer bus, I prefer jeepney, tricycle. So, and is it is it independent of age group? Okay. So, nagre-rely ba yan sa age group yung preference? Ganun. So, and then if you evaluate also categorical survey responses about community needs, parang ganun. So that's the that's the value, or that's the chi-square method. Because you really examine the relationship. So okay, I'm okay now for Monday, so we can continue hypothesis. Keep reading. So Jen, I'm okay. I'll stop share and take it away.